Speed of sound in air using standing waves CPAC. This will be the setup for the experiment. We have a tool column that will be filled with water. At the top we have a loudspeaker connected to a signal generator. Listening to that is a microphone which is connected to an oscilloscope, and at the front there is a ruler which we can measure the height of the water. What's going to happen is the hose at the bottom will be opened, allowing water to empty from the column. This will change the distance between the loudspeaker and the top of the water. As this changes, we will have a period of destructive, as shown, and constructive interference. When we have constructive interference, as shown here, we have a standing wave formed, which means there is an increase in the amplitude recording. Sometime later there will be some destructive interference, meaning no standing wave is formed and the recorded amplitude is lower. When the amplitude is at a maximum, we will have n nodes formed. So in this example here we have 2 nodes formed. As the height changes, we can use the ruler against the sides to measure the distance and allow us to calculate the distance between the nodes. What you need to do is to watch the video of the experiment and record the height when the sound is at maximum amplitude. This can then be plotted on a graph of height versus node number. In this experiment you should find you have a straight line with gradient equaling to half the negative of the wavelength. You can then use the oscilloscope to calculate the frequency of the wave, noting that the time base is set to 1 millisecond per division. That means each of these squares here is worth 1 millisecond. It might be tempting at this point to try and use a shortcut and just use the frequency displayed on the signal generator. This frequency is incorrect as the display is inaccurate, and if you use that you won't get the correct speed of sound. You can then calculate the speed of sound and then analyze and process your data to be awarded CPAC 5. A word of advice here, the uncertainty on the height is very small, and if you tried to plot it on your graph, your error bars would not be visible. So in this instance it's acceptable to have only one line of best fit. There will, however, be uncertainty when it comes to calculating the frequency from the oscilloscope display. So watch the next video, record the data and calculate the speed of sound.